Good morning, grade 11s. Rational expressions and equations. Let's do a quick review here. We want to simplify the following rational expressions and determine any non-permissible values. So if we look at this first question, A, what we want to do is we want to factor. And this is all inspection because my coefficients of x squared are all 1. So if I want to find factors of negative 22 that add up to 9, those would of course be x plus 11 and x minus 2. And our denominator, factors of 11 that add up to 12, would be x plus 11 and x plus 1. So I can see right away that I can cancel those two factors, but before I do so, we also want to find our non-permissible values. So it's determining non-permissible values. So we know by looking at this that x cannot equal to negative 11 or negative 1. So those are our NPVs. And once we have factored, we can cancel our two common factors, and our final answer is x minus 2 over x plus 1. For question C, okay, I think I'll do A, C, and E, and G, and I'll let you guys do the other ones as a try. For question C, we have a difference of squares here on our numerator, so that's an x minus 3 and an x plus 3. Okay, and that's all over a common factor of 6 times x plus 4 times a common factor of 10 times x plus 4 all over x times x plus 3, which is already factored for us. So we want to find all of our NPVs here, and so we know that x cannot equal to negative 4. Right, we're going to look at that denominator. X cannot equal to 0 and negative 3. Okay, those are our three factors in the denominator: negative 4, 0, and negative 3. And now we're going to get out that red pen and cancel common factors. And of course 10 divided by 6, those are both divisible by 2. And our final answer here would be 5 x minus 3 all over 3 x. All right, question C, we have a divide. Okay, so remember when we divide fractions, we're going to multiply by the reciprocal. Our first top polynomial there, 4x plus 20, we can take a 4 out of 4x plus 20 to give us 4 times x plus 5. Our denominator, we can take a 5, and we get 5 times x minus 4. I'm just going to leave this as a divide for now. I'm going to factor my 2 out, and I get x squared minus 25 on my numerator, that DCF of 2, and our denominator is, of course, a difference of squares, x minus 4 times x plus 4. So then I'm going to rewrite this as a multiply. Our first fraction stays the same, and our second fraction, we're going to multiply by the reciprocal. And now when I look for common factors, because normally we look at just the denominators, as I'm highlighting here, the numerator here in our first divide fraction becomes the denominator in our multiply. So we have to look at both to find our NPVs, both of the numerator and the denominator of the second fraction. And in looking at this, we know that x cannot equal 2 plus or minus 4 and plus or minus 5. Note, if we had just looked at the denominator or just looked at the denominators here, we would have missed the negative 4. Okay, so now we're going to get out our red pen, and we're going to cancel those common factors. All right, and we end up here with 4 x plus 4 over 5 5 times 2, which is 10. I guess we can simplify that after if we want. We could have simplified that earlier, right? I could have done 4 and 2, which is 2 and 1. And then, of course, down here, this is going to become a 2. Oops. A 2 and a 5. Okay, so our final solution there is 2x plus 4 over 5x minus 5. Okay, we'll look at G and H in a minute. Those are adding and subtracting, but I'm going to suggest that you pause the video and do B, D, and F as tries. Okay, so you pause that. Okay, so here's the solutions to these 3 questions. Question B. X cannot equal to plus or minus 2, and our final simplified solution is x plus 3 over x minus 2. Question D, our non-permissible values there. X cannot equal to 0, 1, or 5. And our simplified expression is 10 over x. And for our last one, we have 4 non-permissible values there. And our simplified expression is x plus 2 over x minus 3. For the last 2 questions here, or the next 2 I should say, we have to add and subtract. So what I'm going to do is I'm going to start by factoring. We get our 2x plus 3 over 5 x minus 5 plus x minus 4 over x minus 4 x minus 5. Now before I start finding a common denominator here, I notice that within my second fraction I can cancel those 2 common factors. I do know that indeed x still cannot be equal to 4 or 5. Okay, but I'm just going to rewrite this now as 2x plus 3 over 5x minus 5 plus 1 over x minus 5. And that'll give us a simpler denominator to work with. So now what we're missing here on our right hand side is we're missing this 5, and I need to multiply the numerator by 5 as well. So our numerator is now going to be 2x plus 8 all over 5x minus 5. Okay? And I'll just pause the video, or you can pause the video rather, and you can try question H. Okay, so for question H, hopefully you were able to try that on your own. There's a little decomp there. We had to also factor the negative out of the 3 minus x to get an x minus 3, which gave us a common denominator, x minus 3. And so take a look and pause that video and see if you can figure out if yours is the same correct solution. All right. I'd started this, but my computer or my iPad's low. So this first one, and it bought me out. This first question here says stating non-permissible values and solve the equations. This is an equation, and it's actually a proportion because there's 2 fractions and an equal sign. So I just need to cross multiply this one. We can see that our x cannot equal to -7 and -1. And when we cross multiply, we get 5x minus 3 times x plus 1 equals to 5x minus 14 times x plus 7. And so, of course, we're going to distribute both sides there. And we get 5x squared, 5x minus 3x minus 3, and on our right hand side we've got a 5x squared plus 35x plus 4x plus 28. Okay, and we can see that we've got a 5x squared on both sides, which we can just subtract. And now let's simplify our x's. We've got a 2x minus 3 equals 39x plus 28. And so I believe we end up with a 37x is equal to, subtract 28, 31. So x should be 31 over 37. Okay, I'm just going to double check with my NPVs and make sure that that is not an NPV solution. So this should be, which it is not, so that should be the correct answer. Okay, so for question B, I'm going to invite you to at least try and get it set up. Okay, I'll put the solution in a second, but I guess to start we're going to need a 5 over 3x minus 1 plus 3x over 3x plus 1. We need a common denominator, and so we know that both of our factors have to be in our common denominator. 3x minus 1, 3x plus 1. Oops, that should be a 3x. And of course, that's 3x minus 1 over 3x plus 1 on our right hand side. Here we're missing a 3x plus 1. So we need a 3x plus 1 there. And we're missing a 3x minus 1 there. Our NPVs, we can see x cannot equal to plus or minus 1/3. Okay, so once we're set up there, we are going to distribute the numerators. We get a 15x plus 5 plus 9x squared minus 3x all over 3x minus 1, 3x plus 1. And on our right hand side we're going to distribute those numerators again, and that's just a difference of squares, so that's 9x squared minus 1 . Okay, and now our denominators are the same, so we can drop those denominators. All right, and I also note that I've got a 9x squared on both sides, so we can cancel those 9x squareds. And we've got a 12x plus 5 equals negative 1. So 12x is equal to negative 6. X is negative 1/2. All right, so there's the review for rational expressions. Note in this final review, it's kind of a skeletal review. Make sure that you review on your own the rational problems. Okay, the distance, rate, time, and the work problems. All right, there's a few review questions there in your review package at the end of your rational notes. So good luck with that. Let's look at the reciprocal on a separate video. All right, so for reciprocal functions, we've got two functions, one linear and one quadratic drawn. It says sketch the graph of y equals 1 over f of x, which is the reciprocal function of f of x, and write the equations of the vertical asymptote and state the y-intercepts. So what I'm going to do is we're going to start with, there's some steps down here for sketching. Okay, steps for sketching. And I'm just going to change my template here. Okay, the first thing I want to do is note that the x-intercepts are the vertical asymptotes. And that's because, of course, at the point up here at -2, 0, the reciprocal of that would be -2 and undefined. Okay, so that undefined portion, that's what gives us our vertical asymptote, right? Because the reciprocal of 0 is undefined, then our vertical asymptote here will be at x equals -2. All right, and the next step we want to do is I want to find those invariant points. So I know that I've got invariant points at 1, where y is equal to 1, and where y is equal to -1. So I'm just going to move along the line y equals 1 and move along that horizontal line of y equals -1. Find those two invariant points, mark them on the graph. Okay, those would be the same points on both the original linear function and the reciprocal function. And now I just have to think to myself, well, these small y values in between 0 and -1 would become large y values, the absolute value, when I'm thinking of the absolute value. And so, and the larger values become smaller values. And I could, of course, label a few of them, or I can just sort of think that through. Now, if I'm not sure, I can take individual points. Okay, there was a point here at -1/2. -1/2 became -2. There was a point here of -10. -10 would become, -1/10 rather, would become -10. Okay, or if I think of the point here of -2, -2 is going to become -1/2. And one of the questions does say, what is the y-intercept? So our y-intercept here would now be 0 and -1/2. Okay, so I'm labeling that right on the graph. And there we go. Okay, let's look at the next question. Question B. Same thing. If you want to pause the video and try it, that wouldn't be a bad idea. You could pause the video and see if you can get your... Okay, if you gave that video a pause, hopefully you got that drawn. I'll just go through it as well, just in case. So our two x-intercepts are at -3 and -1. So I'm just going to draw those two vertical asymptotes. Right, that would be x equals -3 and x equals -1. We also know that we have some invariant points. So I'm going to look down the horizontal lines here where y is equal to 1 and y is equal to -1. Okay, I'm just going to look across there. Oh, there's a point and there's a point, and y equals -1, there's my point right at the vertex. So now this parabola is going to have 3 sort of branches for the reciprocal function. Okay, we think of each sort of wing very similar to a linear function. Okay, and remember, we never cross the x-axis, because if a number is positive and we take the reciprocal is still positive or negative. Okay, it won't change the sign, so we never cross the x-axis. And for this one here, right, the vertex is -1 is my minimum, and the reciprocal being -1, so the midsection of our reciprocal function looks sort of like that. And I guess the last thing is we need to find that y-intercept. Okay, so it was up here 0, 3, and so of course 0, 3 is going to become 0 and 1/3. Okay, there's our new y-intercept for our reciprocal function. All right. And the last question here says the graph of the reciprocal function, g of x, which is 1 over f of x, the graph of a reciprocal function is given where f of x was a linear function. Okay, so we've got the reciprocal, we don't have the actual linear function f of x. It says sketch f of x and determine its equation. So we can see here that there was a asymptote, or is an asymptote. Okay, there is an asymptote here at x equals 2. So that gives me the hint that, of course, there was an x-intercept at 2, 0 on our original function. Okay, and I also can see that they've labeled here, they've labeled for us the 0, negative 1/2. That's on our reciprocal function. So the corresponding y-intercept on our original function would have been in 0 and negative 2. And so I can just draw a line, whoops, right through those 2 points now. And I can see that would have been my original function f of x. And the question also asks for the equation. So we can see that 0, negative 2, our b value is negative 2. Okay, and we can see that our slope is up 1, right 1, up 1, right 1. So our slope is 1, or 1 over 1. So f of x is 1x minus 2 in y equals mx plus b form. All right, so there is a brief review of reciprocal functions as well. Hopefully that helps in your review for this unit exam. Good luck.